Hello everyone, I am Pradyumna. I will going to discuss the topic crystal system in 3D as the part of my and video assignment. Basically, the crystal structure is combination of space lattice and basis. Space lattice is the arrangement of infinite number of imaginary points in space with identical surrounding. In this picture, we can also see that this is the periodic uh, arrangement of the infinite numbers of imaginary point, and the basis represent of atoms or molecules. So, in this case, I will take the monoatomic. We can take an example like sodium, iron, aluminum, and uh, for the basis we can also take like diatomic like NaCl, CsCl, ZnS, and also three or more than three polyatomic crystals like polymers and protein. So with the combination of these two, lattice and basis, the crystal structure will form. So the atom will placed at the all uh, at the all imaginary points, and it will create the crystal, which is the periodic periodic structure. So to going to going further, like what is 2D crystals and 3D crystal system, there is some important variables and symmetry operations. So as we know that to define crystals in 2D, we have to use variables, uh, two vectors a and b, and one angle, which is we define this as a theta. And in 3D, uh, for 3D crystal arrangement, we have to choose three vectors, which is non-coplanar. So we choose as A, B, C, and for these we have to choose three angles: alpha, beta, and gamma. Because to define a crystal, we need n vectors, so we have to need n into n minus 1 upon 2 angles, where n is the dimension of crystal system. And so these are the variables which are important for to generate the crystal in space. And there are some restriction, because with these variables we can generate infinite number of uh, crystal system, because there is no restriction. So but uh, it is not happen like there is infinite number of crystal structure. There are some symmetry operations which restrict the number of crystal. So these are the translation symmetry which operates on a lattice point, and the second one is the reflection symmetry. So because to reflect a lattice point we need a plane. So this reflection symmetry is a 2D operator, and the inversion symmetry, uh, we need a point, so it is a zero dimensional operator, because we need a point if we have a atom at the r vector with respect to the origin. So if this is a inversion symmetry, we also find a atom which is at the minus r vector with the respect of the origin. And the third one is the rotation symmetry. So because for find the rotation we need a axis, so it is a 1D operator. So with the help of these four symmetries we restrict our crystal systems in space. So uh, when I talk about 2D, so in 2D, because of these symmetry operations, we only have four types of crystal systems present. These are square system. So in the square system, uh, the magnitude of a and b is same, and the angle between these theta is 90 degree. And the second one is the rectangular. So in this case, the magnitude of a and b is not equal, and the angle between these two is 90 degree. And the third one is the hexagonal. So in this crystal system, the magnitude of a and b is same, but the angle between these is 120 degree. And the fourth one is the oblique. So in oblique, the magnitude of these a and b is not equals. So these is the four kind of crystal system present in the 2D. And same in 3D, because of these symmetry operation, only seven type of crystal will present. These are triclinic, monoclinic, trigonal, hexagonal, orthorhombic, tetragonal, and cubic. With the respect of these magnitude of the vector and the angle, on the basis of these variables, we define these seven kind of crystal system. And there are also some symmetry present in these crystals. So I'll going to discuss this symmetry with the help of uh, Wolfram alpha. So this is the picture we can take. Like we can see that in the cubic system, there are rotation symmetry of 90-degree, because we can rotate this crystal cubic crystal 90-degree with the respect of any principal axis. We will find the same crystal. Right, we can see that we have find the same crystal. And if I am talk about the monoclinic, yeah. So in the case of monoclinic, uh, only two-fold rotation will present. Uh, so we can see that after 180-degree of rotation with respect to z axis, we will find the identity. And in the case of others like triclinic, there is no symmetry present uh, except the translation. And in the orthorhombic and tetragonal, trigonal, and hexagonal, there are also symmetry present, but these are not with respect to the principal axis. So it is very hard to show uh, these symmetry in the other cases like orthorhombic and etc. So these are the seven crystal system. So these are the seven crystal systems. Okay, thank you.